Hello, everybody. On today's lesson, we are learning about our first transformation called translations. Oh, just a second. Let me fix this. There we go. So everybody should have the handout. It's in your file. And our objective today is to perform what we call a translation on a geometric object and to write translations in function forms. So remember, we're looking at transformations. Transformations are just functions on geometric objects. We're going to look at translations, reflections, rotations, and dilations. So today's our first one. A translation is a type of transformation that maps all points of a figure the same distance in the same direction. So think of a translation as a slide. We're going to slide an object from one location to another location, and we're going to slide Pikachu. We are going to translate Pikachu 14 centimeters to the right and 4 centimeters up. Now, how do we write translations? In algebra class, you write functions as f of x equals, and then you have some equation. In geometry, instead of the F, we use the capital letter T, standing for translation. And then a subscript, we have a subscript under the T, and it tells us the horizontal change and the vertical change. So ours is 14.4 because our horizontal change is 14 centimeters and our vertical change is 4 centimeters. So we're moving right because it's positive, and we're moving up because the vertical change is positive. If either one was negative, if the horizontal change was negative, we'd be moving left. If the vertical change was negative, we would be moving down. Now, what are we translating? Just like in algebra, when you have f of x, x is your input. Well, here we have a geometric object. Usually we put a polygon in there, but we're going to do Pikachu. And somebody told me I spelled Pikachu wrong. It's with a K. Now, how do we transform an object? When we transform an object, we move every point in the object the distance described in the translation. So every point in Pikachu is going to be moved 14 right and 4 up. So we're going to pick a point. We'll name it A. This is an initial point, INITIAL. And we're going to take that initial point and take your ruler, and you're going to move it 14 to the right. And then we're going to move it 4 units up. And here's my ending point. And we're going to label that A prime. We always use the same letter. The initial point is just the letter. The point that we get after the translation is called the terminal point, and that always has a prime. And the distance we move is right 14, up 4, and that results in an overall movement of this distance given by this arrow, which we call a vector. And now we're going to do the same thing. So how do we transform Pikachu? You can pick as many points as you want. I'm going to pick this point B. And I take B and I go 14 right. And if it helps, you can draw the horizontal line really lightly. And then it's going to go 4 centimeters up. And there's B prime. And notice since A and B prime are connected by a line here, A and B prime, I'm going to connect with a line there. Now I'm going to do the left part of the ear. C, you might want to do a point right here at the bend. I'm just going to do this point right here, C. And I'm going to go 14 to the right, 4 up, and I have C prime. And I notice that A and C prime are not really joined by a straight line, but kind of a curve. So I'm going to do the same thing here, letting my points be the guide. And if you want, you can shade in the dark part. You can color Pikachu yellow. There we go. And you continue and do the same thing. So I'll try the next ear. I'll make that point D. So I go 14 to the right, 4 up. There's D prime. And notice B and D are connected. That's the top of Pikachu's head. Then I'm going to transfer the top of the ear, 14 right, 4 up. So here's an E, here's E prime. Notice it's connected with a slight curve. There we go. Now I'm going to try F. 14 right, 4 up, and it's connected with this curve. There we go. You can color the top of Pikachu's ear, dark color, and continue in the same pattern. Pick as many points as you need. So if I was going to finish, I think I would pick a point on top of the cheek, below, maybe a point at the bottom of the chin, excuse me, to give me this outline. And then maybe a point for each eye, a point for the nose, and a point in the middle of the mouth. You get to choose how many points to translate, but they should give you your guide, and then you can fill in the drawing. When done, you should have a Pikachu that's been translated that's the same shape and the same size as the original Pikachu. It's only been moved 14 centimeters to the right and 4 centimeters up. That's a translation. Now, you can stop the video, finish this. When you're done, turn the video back on, and we are going to translate a polygon. So here we go. I have a function, a translation, subscript 4, -6, and polygon A, B, C, D, E, F, G, H, I. You name polygons by their vertices. This has 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a nonagon. So my horizontal component is 4 right because it's +4. It's 6 down because it's -4. And first thing I want you to do is graph the points. Ignore this. I'm sorry, that was a misprint. It accidentally double printed. But I'm going to graph A, B, C, and as you graph, connect the points so you have your polygon. D, 3, 4, 5, 6, 7, E, F, G, H, and I is back to A. So I'm going to connect all these points. And this is a very odd shaped polygon. Polygon A, B, C, D, E, F, G. Oh, I forgot. Sorry. I missed one. I missed H. Probably because I didn't label it. All right, now we want to translate. So it's important for each of the transformations that we do that you know how to do it on a blank sheet of paper. You know how to transform that shape in the way that's described here, a translation, just on a blank sheet of paper. But it's also important that you know how to find the coordinates and the shortcut. So we could translate this by taking every point and going 4 right and down 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Here would be my A prime. And let me find a different color. Here we go. A prime. And then B, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 down. There's B prime. And we would connect A prime and B prime. And there is this segment translated to the right 4 and down 6. But there's another way to do this. It's with the coordinates. So when we start out with our point -9, 8, a horizontal move to the right adds 4 to every x coordinate. And a movement 6 units down subtracts 6 from every y coordinate. So to find a new coordinate, I'm going to do -9 plus 4. And the new y coordinate is 8 minus 6. -9 plus 4 is -5. 8 minus 6 is 2. My new coordinate is -5, 2. 1, 2, 3, 4, 5, 1, 2. And we can do that with every point. So B, I add 4 to the x coordinate. I subtract 6 from the y coordinate. -4 plus 4 is 0. 5 minus 6 is -1. You can use the calculators if you need to. 0, 1 is my B coordinate, my B prime. I'll do one more. C, the x coordinate starts at 0. I add 4. The y coordinate starts at 9. I subtract 6. So C prime is 4, 3. 0 plus 4 is 4. 9 minus 6 is 3. So I'm going to go ahead and I am going to graph the point 1, 2, 3, 4, 1, 2, 3. That's C prime. I could have got there by going left 4, down 6. From C, either way, I get the same point. And for our purposes, you need to know how to do it both ways. I want you to know how to get the translated point simply by counting right and down. But I also want you to be able to do it by adding and subtracting from the x and y coordinates. So continue on in your transformation. I'm not going to show the rest of the answer. You have to do the other points, D through I. I want you both to find the coordinate and plot them and draw your image. I also want you to show me the calculations of how you found the ordered pair for each of the transformations. Notice one thing, label each point. You're going to label them with the same letter, but the image has a prime. A prime, B prime, C prime, D prime, E prime, F prime, and so on. And when you're done, you're going to get the exact same image, move to the right and down 4 units. These sort of motions are called rigid motions, since they preserve the lengths of every side and the measures of the angles. So when you're done, you'll see that the side lengths are still the same, just like AB is the same as A prime, B prime. And the angle measures are still the same, just like ABC is the same as A prime, B prime, C prime. And when the lengths are the same and the measures the same, and our object has only moved, we call that a rigid motion, or we call it an isometry. An isometry is just a geometric term for a rigid motion or an object that's been moved or turned, but it has not changed size and shape. It keeps the same size and shape. So for the rest of this lesson, I want you to make sure Pikachu is finished and translated. Translate the rest of this object right here. So you see its image, which has moved 4 right and 6 down.